institutions, namely Polytechnic Institute of Tomar, it is the promoter, Polytechnic Institute of Leiria. I asked Sandra to present Polytechnic University of Leiria. Of course, I do apologize because I must use now to the new name. Sandra, do you want to present the researchers from Leiria?
Of course. My name is Sandra Mourato, as Cristina told me. I have with me, and fortunately I have these colleagues present here with me, Annabelle Varga, Miguel Barreto. I am just looking for them, okay? André Fonseca, Luís Aires, and I'm looking up, and João Souza. We are missing one colleague,
Hermano. Yeah.
Okay, I think we will be here just in a minute. So, and oh, sorry, I'm missing one other colleague, Cristina. She's there. Okay, we are just spread along the auditorium. Okay, Cristina, she's from the health school. All the others are from the technology and management school. And we are trying to do our best in Polytechnic area to monitoring and create awareness regarding the air quality, the indoor air quality.
So as you saw, we have another two institutions. We have the coordinator from Nicosia. Where is Edna? Edna, do you want to present your institution, please?
Good morning to everybody. I am Andrade from the University of Nicosia. Despite the I am Brazilian.
Yes.
Also,
Yes.
Our team is actually very big. We are from three different schools: the School of Life and Health Science, the Medical School, and the School of Sciences and Engineering. Today, we just came it's myself and Souzana Achilleos from the Medical School. Yeah. So we are very happy to be here. And I think the project is of interest to everyone, especially now that we are able to monitor the air quality.
And to see some results already.
See results, I think it's important, it's very valuable what we are doing.
Thank you. And Anastasia from the University Democritus of Thrace in Greece.
Yes.
Anastasia, please present your colleagues. Our colleagues.
Thank you for the introduction. It's Anastasia. I come from the Department of Forestry in Austria, where we will have the pleasure of you in a few months from now. So today I'm here with my very good colleagues. It's Kyprianou Verona. She's a physicist with a PhD in environmental epidemiology. And my good also colleague, Stavros, engineer from the Department of Environmental Engineering. And we're working on social mostly. And we have the pleasure to be collaborating in this project. So very happy to be with you today, and we look forward to some fruitful discussions.
Of course.
Okay,
thank you. Thank you. And now I will present the team from EPT. I present to you José Casimiro. She is from the very few hours of sleep, and now I'm changing. Oh, I do not want to do that. So he is our colleague from the informatics, not department, but from informatics. He's a good colleague of mine. Where is who is here? Rui Gonçalves, physicist, okay, from my department, mathematics and physics. Francisco, also from the Department of Mathematics and Physics. And we are missing two colleagues that could not attend today, but they are here or even maybe remotely attending to the session. So we are going to begin with the keynote speaker, Dr. Margarida Belo. She is extraordinary, a very good friend of mine, and she is extraordinary. She has a master's degree in geophysical sciences, specialization in meteorology. She was indeed, in fact, a colleague of mine there in University of Lisbon. And she got her PhD in atmospheric physics. Her CV is very long. I'm resuming a little bit, if you do not mind, Margarida. I'm going to resume a little bit. For whom is interested in following Margarida, we have in the website the full description. So she collaborated with international partners in Aladdin Consortium to improve weather forecast models. So currently, Margarida, I'm going to make a joke. If the weather is not correctly predicted, you are the main responsible, or one of the main responsibles here in Portugal. So currently, she's a researcher here in our Portuguese Institute for Meteorology. I'm shortening the name in the Aeronautical Meteorology Division. And she was responsible for many things that happen here from the meteorological viewpoint here in Portugal. And she currently is responsible for the operational implementation of these products, forecast, weather prediction models with focus in aviation weather hazards here also in Portugal. So Margarida, the floor is yours. Thank you for being present here with us today.
Hello to everybody. So Cristina, thank you for the kind words. And thank you for the invitation and to have the opportunity of sharing the connection between the aviation and climate change. I must say, I will present a review of the state of the art between these two subjects, so aviation and climate change. And so I will share my screen. Sorry. Flip.
Can you share it?
I'm trying because I wanted to share it in.
Anastasia, is there any god related to informatics from ancient Greece that we can appeal upon? Because today everything.
No, I will get there.
Yes, you are a co-host, so you can share.
It's in the mode that I'm not able to do it. Preciso de ajuda. Eu quero partilhar o ecrã, mas quero partilhar neste modo, percebes? E é isso que eu não estou conseguindo fazer.
Husband of Margarida. He also works in IPMA, in the meteorological institution here.
Aqui. Acho que
We tried for the session, we have tried it and it worked. And now it does not work.
Quer screen?
Então vai fazer lá screen. Okay. You are seeing my screen?
Yes.
Yes.
Yes, está a gravar.
Vou falar só.
You are not fully sharing, but we are seeing it.
Okay.
Now is?
Yeah.
It's okay now? Okay.
Yes, okay.
So, sorry for... So, before talking about climate change and the connection, I would like to remember or to learn you why, in fact, the plane can lift, let's say. And in fact, it's due to the shape of the wings. and this due to the Bernoulli effect. So the shape makes that the air goes above the wing faster than below. And because of that, you create a pressure gradient, and this pressure gradient is responsible for the lift. So when the aircraft is taking off with the ground speed, that is what you are seeing in the image above, and the air is passing through the wings with the same velocity in the opposite direction. So in fact, imagine, this is the reason why when the aircraft is taking off against the wind. Because of that, because when the wind is coming in the direction of the aircraft, then you don't need so much ground speed. So it's more efficient to take off against the wind. Another thing that I would like to show you is that several weather conditions can cause accidents, aviation accidents. And it depends on which phase of the flight we are. So in the cruise level, the main effect that is responsible for accidents or incidents is turbulence. In fact, you can see there are two kinds of turbulence. Clear air turbulence, that is, imagine you don't see any clouds or light clouds, and you can have turbulence. Of course, visibility and rain are also a problem. But when you look to the approach phase, you can see that visibility or reduction of visibility is the main key effect. Of course, storms are also important, rain and turbulence. So to give you one example about the impact of storms on aviation, and to show you that even in Portugal, that is known for sunny weather, we had many years ago an accident in Faro airport caused by a downburst. And the downburst is, in fact, what I show you here in the left image. So imagine if you have a cumulonimbus cloud that is on the right. And in certain situations, you can have a very strong downdraft, and this downdraft can create a very dangerous situation for aircraft. So pictorially, you can see the aircraft landing in different phases. And so you imagine in the position one is getting a very strong headwind. In the position two is getting a very strong downdraft, and at the position three, well, he is crashing. And because of that, it's very important to issue warnings concerning the convective weather. So now talking a little bit about global warming. So everybody knows that in the last years, we observed a strong increase of the global temperature, and in fact, this temperature increased not equally in overland or oversea, as you can see in this image. And I can show you also this image about a recent year, and it's notorious that we have a very, very strong anomaly, mainly in the northern hemisphere and in high latitudes. But in fact, the increase of temperature is not equal for all latitudes. You can see in the above image on the left that near the equator, we are warming faster. And in the stratosphere, we are getting cooler. And what you also can see is that this difference in the warming in the upper levels, so around between 100 hectopascal and 200 hectopascal, that is the level where the aircrafts are going. You can see that in this region, you see my mouse, there is a big gradient between the cooling and the warming. And this can have impact on aviation. I will try to explain why. So here we have some scenarios. So to show that in fact there is some uncertainty concerning how it will be in the future. There are some scenarios a bit worse and other more optimistic. Oh, sorry. And many simulations are using the worst and the middle scenario. Okay. And now to try to make the link, I told you that it's necessary to have wind so that the aircraft can lift. But the lift of the aircraft depends also on the density, on the air density. And of course, if the temperature is increasing, we are affecting the density, the air density. So this is the first connection between climate change and aviation is concerning the air density. So in fact, because of this, in aviation, we define the density altitude. That is not really the altitude where the aircraft is, but is the altitude where the density of the air for a standard atmosphere is the same as for the location of the aircraft. And this depends on it can increase if the temperature increase, if the humidity increase, and it decrease if the atmospheric pressure decreases. So, in fact, what is the importance of that is that if we increase this density altitude, we are reducing the engine efficiency, and we need to have higher true air speed, and we have slower rate of climb when the plane is taking off. And this is important because you may need a longer runway, or you may need to reduce the luggage in the aircraft. Okay, so some studies concerning here the LaGuardia airport. So you can see the shift of, you can see the shift of this PDF, and you can see that due to the increase of the temperature in the next decades, you will see that the number of days with the weight restriction will grow. So for instance, for the Denver airport, you can see the tendency, this trend, that the number of days with the weight restriction will increase. For instance, in 2030, you have less than 100 days, and imagine between 260 and 70, you will have more than 100 days of restricted flights. And this is also projected for other airports. So here you have a study for the Canada airports, and you can see the studies, and you can see that there is a great uncertainty, because if you have a middle scenario of climate change is one path, and if you have the extreme scenario, then you can see that there is a huge increase of the number of days with the weight restriction. So this study concerns the takeoff distance. And here you can see that in several parts of the Earth, so imagine Japan, Spain, USA, etc., you can see that the number of meters that you will need to make a takeoff, they are increased, they are projected, or they were already observed to increase, and they were projected to increase even further, okay? So imagine that this can be quite a problem for short runaways, and it can be really a problem for warm climates, like in Southern Europe, and can even be a bigger problem in airports at high altitudes. So now another important thing is the wind at the high levels where the aircrafts are doing the most of the time. So the efficiency of this path, it depends on the wind. And it depends on the wind on these high levels, and this wind is changing every day, like I would like to show here. And concerning the climate change, it's also known that there is a trend on the zonal wind. So as you can see in the right image, there is a trend to decrease the zonal wind in the equator latitudes, and in the mid latitudes the opposite is observed. Okay, so another study using ERA5, here you have the zonal wind at the cruise level, okay, for wind and summer, and here you have the projected changes. So you can see that there is an increase in the Atlantic when you look, for instance, to the panel D, and during summer the result is a bit different. But there are some uncertainties depending on the scenarios. So what is the importance of this change in the wind? So pictorially, you can imagine the historical map where you have this path where the aircrafts can go. And in the future, it's projected that this jet is being narrow. And if this jet is becoming narrow, this has an impact in the flights from America to Europe, and also the reverse. So on the right, I showed you that this impact is impact of few minutes, like you can see. But I have one question. Okay, we have this impact of few minutes. Imagine less than 2 minutes. Of course, 2 minutes for many flights is important, but I would like to stress that natural variability is still very important. And for this, I would like to show you the difference between being in the positive phase of the NO and on the negative phase. So imagine in the positive phase, you will have more depressions in the high latitudes and a stronger anticyclonic. And in the negative phase is the opposite. So what is the impact of having, for instance, imagine 1 year in which you have the predominance of the positive phase of now or the negative phase? So on the left, you have the positive phase. And if you have the positive phase, you can see that you have strong winds in high latitudes. And on the opposite, in the negative phase, you have high winds in lower latitudes. So then you have the path that the aircrafts have to do going to Europe and coming to America. And when you look to this, you see that you have a difference, for instance, of 10 minutes. So imagine, I told you before that because of climate change, you can have an impact of less than 2 minutes. So in fact, here you have impacts around 10 minutes. This is just to give you an idea that even if the climate change is affecting the patterns, the wind patterns, we should take into account that the natural variability is still very, very important. Okay, and on the other direction, you have even an impact of 20 minutes. So another thing that is important the wind also at low levels. And I don't know if you noticed, for instance, last summer we had a lot of strong winds in low levels near the coast. And here you see one image of the coastal jet that you can see near the Cabo de Roca and in south of Algarve, and this kind of wind is typical of our summer, but it will increase or not. Well, this coastal jet has a maximum between 200 meters and 400 meters. And it can be stronger when this Azores anticyclonic is going closer to the Iberian, okay? And it's expected that this situation will increase, in fact. So here you have the tendency to increase this low-level jet, mainly in summer, okay, and a little bit also during spring. So, in fact, if you account for the worst scenario, as you can see, the coastal jet will be more frequent. This coastal jet is important, for instance, imagine for the Lisbon airport or for the Cascais aerodrome, okay? Because in the left image, I show you only the wind near the surface, but remember that this coastal jet, it impacts between 200 and 400 meters. So in fact, it will impact the approach phase of the aircraft. So now concerning the frequency of extratropical cyclones. So you see the winter and the summer situation. And on the right, you have the tendency for the predicted tendency, okay? So it will be more frequent if you have reddish colors and less frequency if is bluish colors. And so you can see that is near our latitudes, there is some decreasing tendency, okay? So now concerning turbulence, I guess that most of you already felt it when flying, this bumping in the aircraft. And this bumping can be strong in some cases. Some people already were injured. And you can, for instance, the luggage can go down, or your head can go up. Well, it can be really dangerous. And some studies say that this turbulence will be more frequent, okay? However, there are some uncertainties because forecasting turbulence is quite complicated. This turbulence forecast is based on many indexes that depends on the wind forecast, and the wind forecast it has uncertainties due to the several factors, but even due to the low resolution of these climate models. So another concern is the sea level rise. And the sea level rise is a problem when you have these airports that are close to the coast and below sea level. And it is projected an increase of the airports that will be in risk in the future. So now I will talk a bit about these limitations of climate prediction. What I mean is the uncertainty in this climate projection. And for this, I would like to remember that these models are solving equations on boxes. And pictorially speaking, you have these boxes, and in the right box, you can see that inside these big boxes, you can have lakes, you can have mountains, you can have clouds, you can have clear sky, and the model cannot cope with everything sometimes. So here I compare the vision of a hurricane in two different resolutions. So imagine in the right, you cannot see a hurricane. And on the left image, you can see clearly the eye of the hurricane. So when we look at climate projections, we should take into account that there is a resolution limitation. Here, I summarize the nominal resolution of these models, these climate global models, and I make the connection between this resolution and the scale of the atmospheric phenomena. So imagine if you want to predict a tornado, you should take into account the scale of this tornado. Or if you want to predict a hurricane, you should have also into account the scale of this hurricane. Of course, extratropical cyclones have a larger scale and is easier to predict. But we don't know how to predict the cumulonimbus clouds with the climate change. So in fact, some errors can arise. I will give you one example of one severe case. So in 2009, we had these towers completely destroyed, and you see the shape of the storm on the upper image. On the left, you have the satellite image, and on the right, you have the radar image. And you can see that this kind of phenomenon is very difficult to be represented in a climate model. Another case is the day where we had a big forest fire, and this was in June 2017, and this was associated with cumulonimbus clouds, and we had a downburst, and this was helping to spread the fire. And this kind of storms that you have here, so imagine on the right bottom, you have the radar image. And if you look to the red and to the orange colors, you can see, in fact, the cumulonimbus cloud. Okay, so at the left, you have the cumulonimbus cloud, and the connection is that that part that you are seeing with the orange and reddish color is the cumulonimbus. And you can see the spread here on the left in the upper levels of the cumulonimbus. And this spread is what you see in the radar image when you look to the color, to the green color here. Oh, sorry. Where is my mouse? Okay. And this kind of phenomenon, they are subrepresented in climate models. So in fact, even if imagine if the climate projection is saying, well, we will have less precipitation because we will have less extratropical cyclones. This can be partially true, but in fact, we don't know if this kind of storms that I'm showing here, they will be more frequent or not. And some studies say that they will be more frequent. But since they have a smaller scale, they are misrepresented in these climate models. So it can happen, in fact, that we will have more of these storms in the future. And because of that, we will not have less rain. We will have more short range rain, let's say. So a lot of rain in short periods. So another important thing is concerning hurricanes and the post-hurricanes. So in the last 2 decades, we have few post-hurricanes that were approaching the Iberian Peninsula. And it is also difficult to predict if these kind of events will be more frequent in the future. So I will stay here. Thank you for your attention. I will be happy to answer questions. Thank you.
Margarida, for your wonderful communication. I do not know if you are going to remain with us online, because I would leave the questions to the end of this first panel session, if you do not mind. Okay?
Okay, before lunch.
Yeah, no, before coffee break.
Before coffee break. Okay.
Okay, thank you. Thank you. So I want to thank you, and now we can go to the next presentation. I'm going to present Souzana Achilleos. I think I very good. Okay, very good. Okay, thank you. Souzana is an assistant professor in environmental health at University of Nicosia Medical School. Has a bachelor degrees in chemistry and from the National and Kapodistrian University in Athens, Greece. She has a master's science in environmental health from Cyprus International Institute for the Environment and Public Health in association with Harvard School of Public Health. And she is a doctor of science in environmental health from Harvard University in Boston, USA, United States. Her research interests include exposure assessment, environmental epidemiology, and public health, and particularly the investigation of sources, fate, and transport and effects of air pollution, including dust storms on human health. So the first presentation, you saw a little bit how climate change can affect aviation and traffic and everything that is under the umbrella of air traffic, and now you are going to see how can it can have a detrimental effect on health. So, Souzana, the floor is yours, please.
Good morning, everyone. I hope I don't make you more depressed. That's not the aim, but unfortunately, the impact of climate change is here, and I think that's things that make us think about a little bit and find solutions and interventions, other mitigations. So, okay, I know how to do this. We all know that, of course, temperature increasing as we're becoming more warmer, and in Europe, especially some countries in the, more eastern Mediterranean, their temperature is warmer, increasing more or faster. So, climate change affects health directly and indirectly in many ways, but it affects more vulnerable population, especially pregnant women. And there are limited studies, but there's some studies that they showed that climate change affects pregnancy outcome and increases the risk of stillbirth, low birth weights, and preterm birth. And that's how temperature and heat stress affects that. There are some possible biological mechanisms, but one way is that because pregnant women go through different changes and physical changes, they don't have the same capacity to deal with heat stress and get that extra heat through sweat. So they lead to dehydration and thermal stress that leads to changes in how the fetus is growing, their function, and sometimes also to the death of the fetus. Thermal stress also associated with oxidative stress. That's also another way to cause inflammatory processes in the pregnant woman, and rupture of the membrane, which causes carriage and so on. And on top of temperature, humidity also is increasing the impact of temperature, which also causes some other adverse pregnancy outcomes. So one main concern is pregnancy loss, which what is defined by the American College of Obstetricians and Gynecologists is the non-viable intrauterine pregnancy up to 20 weeks of gestation. And the most common in terms of pregnancy loss is the early pregnancy loss, which is up to the end of the first trimester. And it's the most common, and it has a prevalence rate of 20%. Even that can be even more. So that means 1 out of pregnancies, they end up not proceeding. And I say that it may be even a higher number because not all of the early pregnancy losses are actually documented, or the pregnant women, they may not even realize that they had an early pregnancy loss. And it is a major public health concern because, of course, affects physical and also emotional pregnant women, their partners, their families, and also increases the burden on society. So finding the risk factors and the reason is important in terms of public health, and there are different risk factors as science is showing, and including environmental risk factors such as air pollution, but also genetics, immunological changes, and other things that are not in the scope. But one of the things is that we want to see, environmental factors, and one of that, of course, is temperature, which is related to climate change. Now, the evidence is limited, and one reason is because pregnancy losses are not clinically documented. So if we don't have the data, it's very difficult to study that. Makes more sense. Thank you. Yeah.
Okay.
Correct. So as I was saying, there's limited evidence whether climatic factors affecting pregnancy losses, and that's mostly due to there is no data, there is not well documented, number and reports about pregnancy loss, especially early pregnancy losses. So our focus, we took Cyprus, of course, because where we are from, and there have access data too, but also one of the countries based in the Mediterranean, Tunisia, and it has been affected by heat waves or increase in terms of number of heat waves and increase in temperature over the decades. And we're expecting to see even more. There's not studies in the region, actually fewer studies than more in China or United States, and I think one in Europe. So we wanted to see whether climatic factors affect pregnancy and the risk of pregnancy loss in Cyprus, so just to provide some first evidence. So for that, we got data. We went through to the health monitoring unit in the Ministry of Health, and we accessed the birth registry data, where we focus on the live birth. So for each date of birth, so for each birth, we get the date of birth and the gestational age of birth. So how long into the pregnancy, how many weeks of pregnant the woman was when it gave birth. And we focused that within 6 years for the capital, so for Nicosia, the main city and the largest city. And in terms of exposure data, the Cyprus Department of Meteorology we can have access daily in terms of minimum and maximum temperatures, relative humidity, and we also have as one of the air pollutants of nitrogen dioxide, one of our main air pollutants exposures. So as you realize, we don't have data on pregnancy loss, and we use live births. So what live births are is actually the pregnancies that gave birth to a living infant. We don't use stillbirths, which is the deaths of a fetus, but that's after the 20 weeks. So we're missing a lot of pregnancy losses before that, miscarriages. So since there's no data, we use an approach that was designed by our colleagues, and this is their study, if anyone wants to look more at the study design. And I'll briefly, summarize this study design, how it was used, since we don't have data on pregnancy losses. So we use the number of live births as a proxy to the pregnancy losses that we see. And I'll guide you through the main steps. So for each birth that we have from the registry, using the date of birth and the gestational age in weeks, we were able to get an estimate of the conception week. Okay. So let's say looking at the first diagram, all the births were for example, between June, July of 2006. If we go back, depending on the gestation week. So we got all live births that they have the same conception week during the calendar week. And so we sum them, all the live births that share the same conception week for each week during the study period. So we have of this 6 years. And for each conception week, so let's say that it was the 7th diagram. So here we see all the live birth conceptions for each week. We try to, see the exposure or link each of that conception week with the weekly exposure from week 0, which is the conception week, to gestation week of 40, which is all the pregnancy from 0 to 40 weeks. So why we did that? So for all the, we know that the association between the live births identified conceptions are the total number of conceptions that happen in each week, minus the pregnancy losses. So that's why we are using this as a proxy. So the more number of conceptions we have that led to a birth at the later stage are, the more we have, the lost pregnancy losses we have. So that's a way to use the proxy. So if indeed there is an association, so the weeks that we have increase in temperature, then we'll also see less live births after at some point, or we will see more pregnancy losses at some point of pregnancy. In summary, we used, I'm not gonna go through the statistics, but it's a type of time series analysis, which we see week-to-week variation of exposure to the week-to-week variation of our life conceptions, and using the conception week as our unit of analysis. And as climatic factors, we use different factors. So we have minimum and maximum temperature, and we got the average of 2. We use the relative humidity, but we also got the heat index based on temperature and humidity. And we also use the variation of the temperature and humidity during of the 1 week of humidity analysis. And we adjusted for years and seasons, but also for air pollution, because we know it's a confounder. So what we actually saw, here are some summary statistics of these 313 weeks of our study period. So we had on average 85 live birth inceptions over the study period, with the maximum temperature on average 28 and the lowest 15. And here on the right, we see us, plotting just the data of the, on the y-axis is the weekly live births, and on the x-axis, the mean weekly temperature without adjusting of anything, without running any model, but just plotting the data. We just first see that as a first sight, there is the higher temperature, we have lower births. But then when we actually did more of the modeling and we adjusted for other confounders, we came up with this, graph. So what is this graph showing is that on the x-axis is the weeks of gestation. So from week 0, which is the conception week, pregnancy starts, up to week 40, the end of pregnancy. And we see here the relative risk, so the chances of having a live birth. So that pregnancy will actually lead to a live birth. And of course, the shaded area is the 95%. So we see basically that we have a relative lower chance that so the lower the relative risk, the lower chances to have a live birth. So the higher chances of having a pregnancy loss. Okay. So anything below 1 means that you have an increase in the chance of having a pregnancy loss. So we saw that, especially during the first weeks of pregnancy. So from week 0 to 9, when we're exposed to higher temperatures, then you have higher chances of pregnancy loss. So that's one of the critical exposure windows that we saw. And the weeks 0 to 1 are also the most critical, the ones that we saw that has the higher impact. And on average, during that week, for every 5 degrees increase in temperature, and then on average, we have 3 pregnancy losses for our population. And we saw this pattern of we having, this week between 0 and 9 weeks for maximum temperature and minimum temperature, and also for heat index, but in lower impact. Here we see relative humidity, the impact of relative humidity on pregnancy losses. It follows more or less the same pattern, with the first weeks of pregnancy to be the most critical. It has a lower impact than temperature, so we on average it's much smaller than your chances of pregnancy loss. Then we want to see variability. So because we know, variability is a big effect on temperature. So especially pregnant women that they go through these physical changes, they are more high, less able to adjust to these temperatures, changes in temperature or humidity. On the left is the effect of the variability of temperature, and on the right is the effect of the variability in relative humidity during the week. So here we see that the effect of pregnancy losses is much later in the pregnancy. So we don't see the, we see the minimum, for example, for the variability in temperature to be between the week 20 and 35 of pregnancy. And the highest impact is during week 26, which on average we have more or less 7 pregnancy losses for each 5 degrees in variability change. And where for the variability humidity, it was between the week 10 to 20, with the highest impact on week 13. So in summary, we saw this sensitive window between for the first 9 weeks of pregnancy, which means that we have fewer conceptions that resulted in actually live births when exposed to increase in temperature or relative humidity and their variability during the weeks 0 to 9 of gestation. With the stronger association of the highest effect during the first week of pregnancy, and the variability had a higher impact later in pregnancy. So meaning that when you're exposed to those weeks, you have higher chance of having a pregnancy loss later in pregnancy. So as a take-home message, what we saw is there limited evidence for us also to compare our results. As I said, there was only a couple from China and one in the United States and one in Europe, but they're all using a different study design. And one of the major in terms of challenge is the no existing data in terms of pregnancy losses. But looking at this, we see that how much temperature impact, maybe more. So one simple recommendation that we would like to put and maybe push this forward is maybe, raise this awareness, especially to the authorities about maybe issuing other systems when there's higher than usual temperatures and some recommendations for this vulnerable population. So thank you for your attention, and also would like to thank all of our colleagues that contribute to that. This is a group work from Harvard School of Public Health, the Rogers School of Public Health, and the Cyprus Ministry of Health. Thank you.
Thank you. Now, as you see, the indoor conditions are relevant. We will get there, but the outdoor conditions also affect our lives. And now I'm going to present another researcher from the project, Stavros Stavropoulos. He comes from Greece, from the Democritus University of Thrace. And he is an environmental engineer with a specialization in atmosphere, energy, climate change. He comes from the Department of Environmental Engineering, and he is currently a postdoctoral researcher in this university, and he is developing a thing I think you all have noticed that is much talked about lately: machine learning and statistical methods to downscale remote sensing data. Okay, so do not forget to share the screen. Okay.
Looking for a laser. Very well,
Okay, Stavros, the floor is yours.
Thank you, Cristina, for hosting this event, this workshop. Thank you everyone for being here. And good morning. I'm Stavros. I want to talk about practical approaches to reduce indoor noise levels. This is something that affects our everyday lives when we are at the university, when we're working at our office, or even when we are staying at our homes. As we all know, we all want to live in a healthy environment, healthy indoor environment. But what does it mean? It means that our environment should have some commodities, let's say, some environmental factors that makes us stay in this facility, in this setting, more comfortable, more enjoyable, more productive. So we have to have a good indoor air quality, meaning that we have to the air to be free of air pollutants. The outdoors not to be so strong, which is something that we distract from what we are doing. Ventilation rate. Another thing is thermal comfort. We don't need something to be in environments that are too cold or too hot. Visual comfort, of course, I suppose you all can see my screen because you have the right distance to see. And last but not least, and very important, is noise comfort, the acoustic source comfort, which means that, now that I'm speaking to you, you can hear me clearly. There is no other noise that cover my voice. There is no something that you want, it makes you not understand what I'm saying. So I would like to address this issue. And it is important because it affects a lot of our everyday life activity. According to the World Health Organization, which is the organization that takes into consideration a lot of factors in order to improve our lives. Noise is something that takes it seriously because it can increase noise and stress when we are in a noisy environment and we can't hear the speaker or we can't focus on our work, we get annoyed. And if we even have a deadline, we cannot concentrate on that. So we're stressed. Another negative effect is speech intelligibility. We can't understand what the other people are saying to us. And so we cannot communicate. If you ask me something and I can't hear your question due to noise, I can't answer. Or if you are in a university and you can't hear the lecture, what he or she presents, then you want to know what the subject is that is discussed. Which, of course, leads to hearing impairment, can't hear anything. You see, there is a link. There is a link from annoyance and then other bad effects follow. Disturbance of information extraction, loss of productivity because you can't concentrate. But even in our houses, in our dwellings, we have problems if there is noise, even if they are produced from our appliances or comes from outside, sleeping disorders. And when we are exposed to that conditions for a very long time, it's possible to have cardiovascular and metabolic issues. So we have to make some changes, make some improvement. As you can see in this picture, which is from the Environmental Protection Agency, the color bar represents some noise levels to decibel. So, yeah, and on the left side is the common outdoor sound levels, on the right side, the common indoor sound levels. You can see the link between the level, the noise and the sound level from outdoor to the sound levels or from indoor environments. I will stay in one only or two examples here. If you have normal speeds at 3 feet. You have your other speaker in a distance of 3 feet, you can hear it. But not if we are speak too loud and make some noise which is equal being a busy highway at 50 feet. So in a library, or you are in your room trying to sleep in your bedroom, in order to accomplish that, which is an accomplishment to have a quiet sleeping time these days, you have to have sounds lower than 30 decibels. So we have to make some interventions to how our settings are organized, are built, and how can we improve if we are in a setting that already is in a situation like a noise one. So the 1 million question is how can we mitigate the noise levels in those environments? There are some easy ways and some hard ways. Some of them are expensive, some of them are cheap and easy to apply. The noise levels, to avoid being in a setting with high noise levels, comes from the first step of construction. So if you want to build an office or a university or a home, even a home, you have to know where to build it, where to construct it. The rule is to avoid building it, constructing it in a region near the highways or main roads with a lot of traffic. Because due to the traffic, you will have a lot of noise. From horns, from the cars, from buses, trains. So, as you can see here, it is a region in a city in Brazil. This is the red line is the main road, and all those are some settings, offices. You can see in the scale here, not very clear though, from black to pale green is the decibel measurements, the noise levels. So across the main road, you can see there is a lot of noise, a lot of traffic, noise from traffic. But as we move away from the highway, you see the situation gets better. So by designing how far from the main road or from sources that will produce noise, will help us make buildings easier, quieter, and lower the noise levels that will affect us. Thus, we can create a more conducive working and learning environment if it has to, if it is for offices or universities. But if you want to build a house, it still applies. You will have a quieter environment to live. I know this is the first one. The first step is a little bit different. If you have already a setting, you cannot take it and move it to another region. So, as an easy way to mitigate this problem without having to locate them, it's to build some barriers, for example, or plant some trees. But we work at sound barriers. But this is something that has to do with exterior, not just the indoor noise levels. The most common thing to do to reduce the noise that comes from outside is to replace windows from single pane to double pane. This will help this will block the outside noise to come inside. So, actually, if you have some more money, because okay, this is something that costs a little bit more if you build a triple pane window, but you will reduce the noise levels even more. With a double pane, you can reduce the exterior noise about 33%, which is enormous reduction. You can enhance the isotope because you will be in a quiet environment, of course, but you will have a lot of other improvements because double pane windows work as insulation factors as well, so you will gain thermal comfort, which can be translated to save energy because you have no energy loss from heating or cooling. About 39 to 53% from recent investigations. You don't have to forget about reverberations. There is a close distinction between echo and reverberation. Echo is when I speak and I hear my voice comes after some period, but in a lower rate, just something like this. Reverberation is when I speak, my words are coming from all over the directions and messing with one word with another. So it seems that what I'm saying it doesn't make sense. This is something that is more common when we have big spaces like this one. Or in big offices, or in schools, or in the hallways. To prevent that, we use panels. That brown wooden-like panel, it's not only for decorative purposes. It works as a reverberation blocker. That's why you can understand me, I hope, more clearly. And there are a lot of panels that can be used nowadays, which are not only for noise reduction, but decorative and designed equally to make the room more beautiful. So you would have wall panels from various materials. It could be from fabric, it could be from absorbent materials that will absorb more noise bands, sound waves. It could be from wood, from a lot of materials. And that's why the cost depends on the materials that are manufactured. You can have ceiling rafts and baffles, something like that, or this one, which is some vertical slashes it's not only when you go to an office, especially when the offices nowadays are more designed, well designed. It's not only for to see them and say, wow, there's a very nice office. It has its purpose. Its purpose is to minimize the noise levels. But you can have it as slatted panels as well. It is something I've seen in the investor proposal as well. But so this is something relatively cheap method, but a very effective one to reduce the reverberation. And in this way, you can reduce it by approximately 30% and improve the communication. Those two diagrams are from Cacciareo et al. 2015. I would like to point two things. In those pictures, you can see these panels that are installed in different positions in a room. Here are at the back of the room. This is a classroom. These here are 50% of the back, 50% of the ceiling. This is on only on the back of the ceiling, and this is in the middle of the ceiling. And they try to see how the clarity of the speaker improved and how much the reverberation rate is reduced. As you can see here, this is the reverberation type, and this is the frequency. So you see they decrease. With all those interventions and with all those installations in different days, in different spots, in different areas, the result is the same. The reverberation time is reduced. But the most effective one is when you apply them in the air wall, which is actually the best solution for clarity. As you can see, the result is the same. They all improve the clarity of the speaker. So everyone can understand what the speaker is saying. And last but not least, something that we limit in all facilities when they have heating, ventilation, air conditioning systems. Those systems produce noise. Even we don't understand it clearly because it's a steady one, it is a noise, which could be generated by the fan, even though the exterior unit is covered with some sound blockers. The noise of the fan can be transferred via the ducts. So we have to make some intervention to reduce those noise levels. Or it could be due to the vibration of the fan. Or it could be during the noise, due to the noise that comes from another room that is connected with the same ventilation system. And the noise can be transported in here. And we can hear what the people in another room say. So this could be mitigated by normally probably installed and make some adjustments to the parts of those systems, the way we are working, in order to operate properly. So, just to sum up, if you want to minimize exterior noise, internoise, and have better to be in a better and quieter environment, avoid something that's it's near main road. If you don't have this chance, then you could close your windows, double or triple pane windows, use absorbent materials on walls and ceilings to minimize the reverberation time, and to you can try to minimize the noise spectrum that comes from HVAC systems. Thank you very much.
I think these three communications were very well representative of the number of ways of certain research questions that we might pose. And the presence here of the representatives of municipalities are highly relevant also, because we have an aerodrome in Ferreira do Zezer. So it is highly relevant. The first communication, I think, is highly relevant for us, because for those who do not know, that aerodrome in particular is very relevant to the fire departments around the Little Tagus region, because it's near the Zezer River, where the helicopters and even the airplanes get water to the fire season, within the fire season, to be able to, in this region, to be able to attack the fires. Also the sound is very important. It could mitigate in education, higher education institutions, or even in other utility edifications within the municipalities. I think is very relevant. And in health issues, the presentation of Souzana also is. I will leave 5 minutes for questions, because we are a little bit delayed due to the technical problems. And I will ask if anyone has a question, please raise the hand and we will unmute the sound. Here in the auditorium first, anyone wants to ask a question to our guest speakers? No one? Okay, and in remote viewing? Casimiro, anyone raise the hand?
I'm not seeing. No, not yet. No.
No questions. Edna has one. Okay.
So it's for Margarida.
Okay, Margarida, are you listening?
I'm not an expert at all.
Yes.
At all, but I was very curious. So in the future, then we will either have longer, how you call it,
Runways?
or we will have to decrease the size of or restrict even more the luggage that we're taking, correct? That's what you mentioned.
I think both.
Is it either or is it both? And then what would be the solution for, since I don't think that we are going to, in some cases, so when we refer to Rio, for instance, Rio de Janeiro, one of the airports that we have is within the city. Yeah.
It's the same thing in Lisbon.
And it is very, very short. So how would that work?
Okay. I think that there are several possibilities. When it's not possible to increase the runway, one thing that can be done is to organize the flights to be more concentrated on the morning, early morning, or in the late afternoon and night, so to avoid the period of higher temperatures. So this is one thing that it can be done. So imagine that you have a forecast that the maximum temperature will be more than 40 degrees, for instance. And you know that in the next day you will have more than 40 degrees, or in the next 2 days. Then I think you should have the flights more in the early morning and in the late afternoon and even during the night period, because then the temperature will be colder. The other thing is to say to the passengers that they cannot have a luggage. Well, they have to reduce the weight of the luggage. These are the simplest solutions, I think. But this information is also important when you plan to build a new airport, for instance. If you plan to build a new airport, and if you are in an area that you know that is a warm area and it is altitude, high altitude, then you can have a problem. So, for instance, in Portugal, we have not very, the altitude of our airports is not high, so this is good. And in the airdrome of Beja, we have very warm temperatures, so this can be a problem from this point of view. Fortunately, it's not very high. But for instance, imagine Madrid is higher than our airports, and it can have also quite warm temperatures. So it can happen that in the future they have to restrict the weight, and they should put the flights in late afternoon, night, and early morning.
I think that those solutions are possible, of course, but then you have the problem of noise. The people, for instance, in Lisbon, noise restrictions with flights during the night, due to the fact that the airport is in the middle of the city. But in some cases, it's not the only case. You have other airports, but we are trying, still trying the new one.
Yes, but when I say during the night, I don't say after midnight. I say after between 10 to 20 local time and midnight, for instance, is already cooler. Or for instance, between 7 and 11 is cooler than to have at lunchtime. And Lisbon is not a problem so big, like, for instance, if you have, imagine that Lisbon will have an altitude of 1,000 meters, then this will be a greater problem. Fortunately, Lisbon is not so high. But when you have an airport that is at more than 500 meters or more than 1,000 meters high, and if you have warm days, then you have a problem.
Yes, I'm also thinking about Greece with small islands and the airports there with high temperatures, and Nicosia also, the airport of Aashna, near the sea. They will have problems in the near future because there are not enough room to enlarge the runway size. So thank you, Margarida, for your contribution, and thank you also, Souzana and Stavros. Now we will have a brief coffee break, okay? Please be back within 20 minutes, more or less, in order for us to reduce a little bit the delay of the beginning. And now for the students, hands-on, and I will in the beginning, do you still recall what were the levels of CO2? 565 now. Come and see how it is, with the doors closed, more than 1,000. Okay, it's doubled, more than doubled, levels of CO2 here inside the class, inside the auditorium, okay? So please go. See the relevance of ventilating regularly the classrooms, in this case, this auditorium, okay? It's very relevant. So. Entre para os alunos em português, está a passar umas folhas das atividades que vamos realizar para vocês fazerem o favor de assinar, colocando também a instituição no meio, ok? Tem uma coluna para a instituição, para atestarem como que estiveram a participar agora nestas duas atividades que estão mais vocacionadas para vocês. Is there any undergraduate student from abroad here? No? Okay. Okay. Welcome again. Okay, let's start our second part. Okay, so continue now with the first panel, focused on climate change impacts and technical issues. Okay. Okay, so we'll continue.
the theme of this panel, as you know, is the climate change impacts and sustainability, air quality and well-being. We'll continue now with a case study on microbiological indoor air quality at SPG Leiria campus, that most of you know, and it's going to be presented by André Fonseca. He is an environmental engineer with a master's degree in hydraulics, water resources and the environment. André works at School of Technology and Management of the Polytechnic Institute of Leiria as a senior technician in the bioscience and water treatment laboratories in the civil engineering department. Outside of his professional life, he enjoys traveling, writing poetry, acting in theater, and playing sports. Please, André, you may start your presentation.
So, good morning, everyone. My name is André Fonseca. I'm a laboratory technician at the ASTG campus of the Polytechnic Institute of Leiria.
Eu quero a imagem do ecrã.
Não é isso, queria apanhar aquela câmera, mas alguma.
So, as I was saying, I'm a laboratory technician at the Polytechnic of Leiria. Sandra invited me to be a partner in the BreathIN project, and I've been helping essentially with the assessment of the microbiological indoor air quality. So, I will start by saying something obvious. That is that there are only a few certainties in life, and one of them is that So I was saying that there are only a few certainties in life, and one of them is that microbes, just like salts without pairs, are always everywhere. Doesn't seem to be working. Microbes, just like salts without pairs, they are always everywhere. They possess what we call ubiquity, which is the ability to thrive in a wide range of conditions, from the human body to the most extreme environments. This means that they are also present in classrooms, and as you know, sometimes they are also very extreme environments. So, we know that good air quality is crucial for health and well-being, as it directly impacts students' learning environment and the overall prospect.
Tudo a correr bem.
Murphy's Law.
Yeah, completely today.
Pura e simplesmente fecha a página, essa página.
Sim, já cortei. Já estamos.
So I was saying that ensuring a good indoor air quality is crucial for health and well-being, as it directly impacts the students and teachers' learning environment and the overall outcome. And even though not all microorganisms are harmful for us, high concentrations of fungi and bacteria in indoor air can pose significant health risks. I will shortly address some of these health risks. The most common ones are respiratory problems, because the inhalation of fungal spores and bacteria can cause respiratory problems, especially for people who already have pre-existing conditions like asthma or chronic obstructive pulmonary disease. Also, some bacteria and fungi are known allergens. They can trigger allergic reactions, like, for example, rhinitis, conjunctivitis, and skin rashes. Some of them can also cause infection. For example, Aspergillus, which is a fungus that is found in food, can cause aspergillosis, a serious lung infection. Another symptom of the presence of these microorganisms can be toxic effects. Some fungi produce mycotoxins that can have toxic effects in our body. Also, the sick building syndrome is a condition that can be potentiated by microorganisms as well. That is when occupants of a building experience acute health effects that are linked to the time they spend in that building. This could be nausea, dizziness, headaches, irritation of the eyes, irritation of the throat. And last but not the least, some fungi can also produce volatile organic compounds that can irritate the mucous membrane and the skin. So, with this said, it is important to make a regular assessment to identify and try to mitigate these health risks. So, we set out to monitor the air quality, microbiological air quality at our campus, and this was new territory for us. We didn't have much experience on this, so we chose the best method and we looked into the legislation and to the standards that regulate the compliance for service buildings like the ones we have at our campus. So we had to choose the operational conditions, namely the incubation temperature, incubation time, culture media, and volume of air to sample. And for example, if we took a look at the standard that applies for measuring airborne microorganisms, it is said that incubation temperature can go up to 2 weeks. However, we find out that if we let our agar plates left for 5 days or more, they would look like this. So, sure, this would make a great and cool Instagram post, but it doesn't help us to meet our goals. So we had to set the experimental conditions, and we decided to, regarding incubation temperature, use bacteria at 25 and 37 degrees and fungi at 25 degrees. This approach allowed us to study not only the mesophilic bacteria that thrive at ambient conditions, but also the human origin bacteria that grow better at 37 degrees, and they are typically part of our microbiome, and that they can become airborne through activities like talking, sneezing, coughing, or shedding skin cells. Regarding the incubation times, we use 3 days for mesophilic bacteria and fungi, and 2 days for the human origin bacteria. Bacteria were cultivated in triptych soy agar and fungi in malt extract agar. And we used a volume that ranged from 100 to 250 liters, but we settled for this last. The sampling procedure is very straightforward. We use an impaction air sampler. We open the perforated lid and we disinfect with alcohol the lid and the plate hole. Then we put this agar plate, we take off the lid, we screw the perforated lid of the equipment, and we set the volumes we want to sample. This takes a few minutes, and afterwards, come back, we take the perforated lid, we close the agar plate lid, and we bring this agar plate to the laboratory. You can see the marks of the impaction of the air that flows through the equipment. So we place it in the incubator at the desired temperature, and it stays there for a couple of days until the colonies start to grow at the surface of the agar plate. Then we count the colony forming units, CFU per cubic meter, using a colony counter. In the end, we ensure that all biological material is decontaminated in a sterilizer at a high temperature before disposal. Regarding our sampling sites, we run several tests, but we focus essentially on 2 classrooms that are computer classrooms. The civil engineering project room spec with an area of 72 square meters, and game lab 2 with an area of 73 square meters. Here we see Rodrigo and Juliana, who were actively participating in the sampling campaigns and made a valuable contribution to this project. So the results, the most relevant results we got are going to be shown here. So in our initial approach, we compared the microbial contamination in a day with occupancy, comparing with the day without occupancy. For the spec, we realized that in the days without occupancy, the microbial concentration were lower than in the days with the occupancy. This highlights the relevance of the human activity in the classroom that elevates the microbial counts. For the game lab 2, we found the same pattern, much more microbial loads in days with occupancy comparing with days without occupancy. The green line represents a reference value that is exceeded almost in every occupied conditions. We then made more tests, and recently on the 19th of November, we did another test, which the goal was to compare the microbial load right after a class or in the middle of the class with the microbial load when the room had been emptied for a few hours. what did we realize? For instance, here are the class that went from 8 a.m. to 12. Some of the students who were in this class, at the end of this class, are here. And we found out that there were a big microbial contamination after the class. This suggests that the activity in the classroom elevated the microbial counts. When the room had been empty for a few hours, a new sampling was done and the microbial counts decreased significantly. We also monitor the CO2 and we found a correlation between the microbial counts and the CO2. It should be in ppm, not micrograms per cubic meter, but we can see that since the beginning of the class, the CO2 levels have risen and peaked by the end of the class. Then they dropped and they peaked again when there was a new class happening. We found the same pattern also in game lab. Lower levels when the room was empty and higher levels in the middle of the class. Also for CO2, we found the same behavior, levels that have risen with the following of the class, and then they dropped when the class was over. So these results and the work we are doing helped us reach some conclusions. First one, and probably the most important one, is that our study highlights the critical link between occupancy, microbial counts, and CO2 levels. There is an impact, a direct impact of occupancy on microbial counts and CO2 levels. Also, we believe that proper ventilation and regular monitoring are crucial to mitigate health risks associated with these high microbial loads. Future work, future research can expand to new classrooms, to test the test of different ventilation conditions, testing correlations with external samples and parameters like humidity and temperature. And we confirm that ensuring good air quality is essential for creating a healthier and more productive learning environment for students and educators. And by doing so, we are contributing to a much better quality of life. And as the Pearl Jam song suggests, we can all breathe in a better environment. Thank you very much.
Thank you, Andrade, for your amazing presentation. I think I can say so. Please don't leave. Okay. Since the next presentation is going to be more practical, we can have now a moment for questions, if there is one. Sure. Please.
Congratulations for your presentation. My question is related to the mitigation.
You should speak louder, also otherwise.
My question is related with the potential mitigation measures. I see that you mentioned the regulation, but do you have trouble thinking about mitigation measures?
Yes, most simple one and most effective is ventilation. Open a window, open the door, and empirically we had already realized that it works, and it dropped significantly the levels of microbial load and CO2 concentration. So I think the most effective measure is try to ventilate the rooms, try to educate teachers and students for the importance of opening a window, opening the door, so that the air can renovate. I think it's the most important one. And I think in the scope of this BreathIN project, we're going to test the effect of houseplants in the indoor air quality, which can also be a promising field.
If I may, just to complement. Just to complement, we have tried in some classes with our third-year students and just open the window for the break, during the break. If Cristina, do you let me speak or not? So just open for half an hour or 10 minutes, 15 minutes, it's enough for decrease the CO2 levels. Okay, the microbiological aspects we haven't tested because it's a small time, but CO2 drops drastically, okay? Because we cannot expect that during the winter we have the windows open for the entire class, okay? It's not possible. But during the break, a window back in the back of the classroom, it's enough. Please, when you are in the class and you feel that the air is getting stuffy, please ask your teacher, can I open the window? Okay, and tell them that you have proofs that that is viable. Okay, any more questions? Well, I have one question to Andre. I think that we all should have a new workshop with him to learn how to do this nice presentation. I think you are going to be hired by everyone.
No worries, and I'm available to go to Cyprus, to go to Greece.
Okay, thank you very much, Andre. Andre is being very helpful in our institution with this kind of work. Okay, so now I'm going to present the final activity. It's not a presentation, it's an activity. Please, I'm just going to get my notes to present the speakers. So the name of the next presentation will be that will be an hands-on activity. It's entitled The Illuminance and its Relevance for a Good Indoor Environment and Well-being in Higher Education Institutions. It will be presented by 3 colleagues from EPT, Cristina Andrade, who holds a Bachelor in Geographical Engineering and a PhD in Environmental Sciences. She has been teaching at the Polytechnic Institute of Tomar since 1998. Currently, she lectures in Mathematics and Physics departments and has been the director of the Natural Hazards Research Center at EPT since 2014. Her research focuses on natural hazards, extreme events, and the impact of climate change on the environment. The other presenter will be Francisco Carvalho, that holds a PhD in mathematics with research activities related to statistics, author of several research papers and book chapters, member and chair of several organization committees of international conferences. And finally, Rui Gonçalves, that is there, that holds a PhD in geophysical. Oh, I'm not going to present from here. Ah, okay, sorry, Rui, but Francisco just close the file, okay? I think he doesn't want for me to present you, okay? Then you solve that with him, okay? So Rui Gonçalves holds a PhD in Geophysical Sciences and Geoinformation. He teaches the area of physics at the Technology School of EPT and is the author of several research papers and books. Okay, so now I give you the floor, and I'm very, very curious about what's going to happen here. I hope so.
Deixa ficar. Para ficar correto nas colunas.
Eu queria, não sei se vai dar.
Quando acabar as colunas fora.
O meu liga para o USB e a linha. Banana, vídeo e som. Não, é isso. É isso.
Why are we here? Where do we come from? These are the most Why are we here? Where do we come from? These are the most enduring of questions. It's a story that we wouldn't be able to tell were it not for the one thing that connects us vividly to our vast cosmos. Light. Through light, we can stare back across the entire history of the universe and discover how it all began. See, those ancient beams of light are messengers from the distant past, and they carry with them a story. The story, the origin of the universe. Gaze up into the night sky, capture the light, and read the story of the universe. Isn't it a wonderful thing? We are part of the universe. Isn't it a wonderful thing? The story of the universe is our story. The story of the universe is our story, carried on waves of light. Wave after wave after wave of light. All colours of the rainbow, colours of the rainbow. Wave after wave after wave of light. All colours of the rainbow, colours of the rainbow. Light can transport us to the past, and we have become virtual time travellers. Night falls, darker and darker, and the universe fades into view. Night falls, darker and darker, darker and darker. Stars being born in distant realms. Alien worlds created by gravity. Stars that shine with the light of 1,000 suns. And vast swirling galaxies. These waves of light are messengers from across the cosmos. And through them, we have discovered the wonders of our galaxy, frozen in time. Gaze up into the night sky, capture the light, and read the story of the universe. Isn't it a wonderful thing? We are part of the universe. Isn't it a wonderful thing? The story of the universe is our story. The story of the universe is our story, carried on waves of light. Wave after wave after wave of light. All colours of the rainbow, colours of the rainbow. Wave after wave after wave of light. All colours of the rainbow, colours of the rainbow. Billions and billions of suns shining in the sky. The story of the universe, carried on waves of light. Gaze up into the night sky. Capture the light and read the story of the universe.
Ora bem, então espero que tenham gostado desta viagem desde os confins do universo, onde, no princípio, tudo aquilo que surgiu, vocês viram ali de uma forma fantástica, descrita por Brian Cox. Acho que vocês deveriam ter curiosidade em procurar os vídeos de Symphony of Science, onde até Carl Sagan, para mim, o meu inspirador para ser hoje parte desta experiência, e gostaria muito que vocês fizessem essa pesquisa. Now in English, for our overall public audience, I told the students present here that I hope they had enjoyed the journey from the womb of several galaxies during the Big Bang until now. Here in this classroom, when we are going to make some experiences with light. Okay? So you have here several experiences that we are going to conduct with light, and I now leave the floor to Rui. Okay? Rui.
Good morning. We can start with simple demonstration of the behavior of light that we learned several centuries ago. How the light behaves when it interacts with our materials. The relation between light and matter. Here we have a table where we can show the laser beam, the two lasers beam. You can use one beam or several beams. They are parallel beams to show the behavior when they fall upon a piece of in this. Today we have here not glass, but plastic lens to show this effect. Cristina also told about the names of some refraction. We have also
dispersion.
Here, very easy. Talk about refraction, and we learned the way these light beams behave when we have this interaction.
You can look to this to the other side of the auditorium to see. Okay.
So
the behavior.
For the students who is here that have learned about the optics, geometrical optics in the school here, do you have some kind of knowledge about this or not?
Do you have knowledge from optics? No, perhaps not.
It's a matter not so well explained in, at least in my time when I was a student, the optics is very worked in the school. So I can put here, and you will see now. Here it's better because we have this break here. Which is not full down. And we can see the first thing that we talked about is reflection of the light. You see that when I turn, we see the light in the laser beam reflected. Unfortunately, I have only this red laser. I have also here, but it's a manual one, a green laser. And we can see that if I do exactly the same angle, we will have the same refraction angle. I talk with my students and say that reflection law is democratic. What it means, any color photon will be reflected in the same way.
So democracy exists in the reflection of the light beings. This is the first one, reflection. The other one that Cristina has told is refraction. What is refraction? Refraction means that the beam, when it interacts with in this sky, in this way, with this parallel length here, will be disturbed and will continue, but in the not the same direction. Will be refracted, will be deviated. So if you look careful, we see that it's no longer going the straight ahead, but is in that direction. And then when it leaves this plastic lens, it goes again in straight line in that direction. So one of the first things that we learned about this, because we learned in the 18th century, the Snell's-Descartes law, that we can calculate the deviation that we see in our lens, and that deviation is because this material is denser, it has a higher weight than the air outside. And the refraction that we are seeing, the breaking in the beam, laser beam that we are seeing here, only occurs in one place, in the border between the air and the plastic. The refraction only happens here and then here again. So when we construct the lens, we do the surface of the lens, knowing that the refraction only occurs in that border. That's why we pay a lot of money on our glasses and so on. The surface where this phenomenon occurs must be very well constructed, very well smooth. Something like the shape must be taken and it must be constructed at least 1/10 of the wavelength of the yellow light, for instance, middle of the spectrum. So, and what about the interior of this lens? Must be of the homogeneous material to have the refraction index must be here. The refraction index is the relation, is a ratio between the velocity of the beam outside and inside the material. In this case, this plastic has an index about 1.5. In the vacuum, the relation is just 1, it's 1, the index of refraction. So the material must be very uniform, the density of it must be always the same. That's why, again, we pay a lot of money for our glasses, because the surface must be well done and the material inside must be what we call optic, not window glasses, it's not homogeneous like our own glasses. So we can now show that learning these small but powerful laws, we can construct our optics to do what we want. For instance, I want to focus and I do this. So I can see that this lens here, this lens, because I have this curvature here, I can focus these 5 beams of light into this spot. Well, our body does this ever since, because our eye is like this, and our retina is here for one classes. Our retina is here, and we focus our roles because we use naturally this kind of construction in our own body. So one more thing about light, about all of this, of the perfect levels of light to work okay in our classrooms. We have Why we see light? Why? Because we are very fortunate. We have cells in our body that have the ability to pick the electromagnetic spectrum and convert those information, those photons, into electric impulse, and we create image in our brain because of these cells. It's one of the most important things that we see and that we work. It's working with light. We are always working with light, so the levels of light must be correct for everything goes okay. So okay, you can.
Now we are going to do some experiments. And for some of you who are not familiar with the optical properties of light, maybe they seem like magic tricks, okay? I want a volunteer from the audience, a student from the audience, please. Let's make some magic. Come on, one volunteer, one student. This activity is for you. Oh, Lordy Lord. So, I have here, maybe now we could see what this camera is producing here for all the audience to be able also here and not only remotely to see what we are doing now, please. So, in this moment, we have fingers. We are pointing fingers to someone. You were very naughty. So you were very naughty. We are going to point fingers. And now they are pointing to where? To our or to your right. Okay. So I'm going to make some kind of magic. What happens if I put this in front of a recipient with water? Let us see. Let's just, or behind, yes, behind in this case. So, Francisco, can you help here, please? The camera? No.
So that's right.
Check, what happened? See, what happened? Oh, well, but the naughty person is where? It was on the left or now on the right? What happened? They changed from the right to the left. This is due to the property that some of the properties that you have seen previously in the video and explain here also.
This
here
is now in the upper side.
Okay. So pay attention when you want to point out to a naughty person. Beware if you are in front of a recipient with glass and water. Okay. So the optical illusion is no. The naughty person was on that side. Okay. So now I'm going to do another magic trick. Let's see. I have here two bars with different colors. One blue, one red, and I'm going to do another magic trick. Okay, let's see if I can pinpoint. Francisco. Okay. Okay. See what happened? Red and blue. Red and blue. Whoa. They no. It was all right. It was all right. They were changing. And see what happens. Red and blue. And now what happened? They are exchanging colors. And they eat a little bit of pastel de nata because they are enlarged. Aren't they? You see? Another magic trick. Optical illusion, of course, but magicians sometimes use these kind of tricks with mirrors and water and so on and other surfaces. I don't know if you are seeing here from this side. Okay, you are seeing? So this is another trick that lights. That's why sometimes when a crime occurs, our eyes may deceive us, and we are not good witnesses because our eyes play tricks on us because of some of these phenomena. Okay, another trick. Do you believe in aliens? No? Well, I do not know if they exist, like witches, but even though I'm going to, no, it's not the gray ones, it's again one gray and one blue. Let's see if we can manage, if we can exchange and maintain the heads and split the bodies of these aliens. Okay, capital sheet.
Dobra o desenho, baixo o desenho.
Sim, eu sei só que. Okay.
Okay.
Now, let's see. Oh, finally, they are exchanging outfits. So we have the red alien with the blue head and the blue alien with the red head. So these are all things that are related with the phenomena that we have showed you. And of course, it's an optical illusion, but based upon the laws of physics. Okay? So I have another one. It is not totally what we meant to do, but we have here, let me check, 2 glasses with liquids inside. And I'm going to try to almost disappear one of them, okay? So, this is important. Okay, so I have this one, and take a look. If I manage to do some magic, it does not work. This is water on water. So let me check. I need the paper that is behind. I think. Okay. So I have another one still on water. Oh, it is worse. It is worse because what I have inside is oil. Okay. Now let us see on another environment what it is going to happen. Okay. Let me check. Okay. I still not could do great things because the liquid inside of the tube is water. Okay. So let me see if I can finally do a little bit more of magic. A big mess for the cleaning ladies to wipe. Oh, now it's different. Not totally, a totally disappearance, but almost disappearance of the glass. You see? What is happening here? Ui?
Yeah, the refraction index is the same. So
Yes.
we would have.
So the oil, within the oil, the glass almost disappeared. And if it was glycerin and not cooking oil, as we use here in our experiment, the glass almost completely disappeared. Okay? So the viscosity, the density of the fluid is also highly relevant. Who is going to show you on another perspective?
Okay, we have here the positive lens. We see the focus here. I can show you now. I can call it a negative lens, perfectly the opposite. And we have a diverging beam. Similar to that experiment, if I tangle together the two ones, they will be similar to this one. I put this here. You will see no behavior because I cancelled this curvature one with the other, and the result is the same as no frontier here, no border here. Yeah. So it's similar to that. Yeah.
So simple magic tricks with optics, optical illusions, but a lot of physics involved in this. Okay? So, of course, we are playing with light. Now, do not forget, in the video that you saw first, there was, what? No, light. First, there was light. And then, how can we measure light? Do you feel comfortable now, right now, to see with this illuminance that you have, with this lighting that you have here in the class, in this auditorium? Are you feeling comfortable? Do you see properly, or do you make, like me, an effort to see, like previously I could not distinguish which one was the tube with the water and with the oil? This is because perhaps the luminance is not as good as it should. So now, please, two volunteers. These are lux meters. These are lux meters, so they are going to measure light. Okay, it's not quite the term that I should use, but now I'm going to use it, okay? So I need someone from the audience, a student perhaps, that could be here and to make some measurements, please, okay? And we are going, oh, volunteer, bravo, applause. Woman, of course. And now, Francisco, if you go with her and the map of the room. We made the map of the room. They are going to tell me which are the values of the measurement, and I'm going so, Francisco, go and tell me the place. the column and the row, please.
Vamos assim, onde é que nós fazemos?
Mas assim só partilha uma só, não partilha estava toda. Então não tem
Quanto dois?
Sim.
Let it stabilize a little bit and round the number, please. You can tell me the. Sorry? In what row?
Muito bem.
Sorry. 10-3? Tinhas dito?
28,3.
Linha.
Esta é uma 5 e a 10.
Entendi, 2,4.
72, aonde?
Esta é aqui. Uma 5 e a 6.
Aonde?
É na 5 3.
So, these were values with the lights off. For auditoriums and conference rooms, the Portuguese norm tells us that the level of illuminance should be 500. So the red color should be green within this interval that you see here. Okay? Now we are going to experiment with the lights on. So there was for lighting. That's why you are like me, that I must use glasses to see, have difficulties to see. And now there was light. Oito, 208. Oh, now something changed. No.
Olha que lá, estou lá. Primeiro dia, calcula aí.
Vamos avançar. 293 Holanda. Queres que eu vá contando aqui? Eu estou com a mesma folha. Excel.
Sim.
308,6.
329.
Wait.
Just one more, please. Pulsation. Okay, now I'm going to input here, properly input here the values in order for you to see the difference with lights on and with lights off. So we had an improvement here. We had 72, now we have 166 here, and here, and here is, sorry, I did not understand the row. Okay, so you see the values with the lights, we had lights, but there was not enough light for us to be able to properly see, and this caused stress, this caused fatigue, this caused serious health issues if the illuminance is not within the regulation, within the norms. So I'm going to show you the PowerPoint presentation that I have interrupted with some values. And let me see if I'm sharing it. I'm sharing it. Casimir, no? Okay. I'm going to share here PowerPoint. Okay. So what we were measuring was the illuminance with the lux meter that you saw your colleague to handle. It is very, very easy to handle. Of course, this is an experiment. We did not make the proper measurements. We did not have the type of light source, the surrounding environment, the distance from a light source, etc. in consideration. But this is very, very important in a working environment because it enhances visibility and accuracy, reduces eye strain and fatigue, promotes, of course, safety, improves productivity, and the compliance with standards is very, very important. In a world that demands sustainability, energy efficiency is also a must-have, okay? So these are the recommended illuminance within the Portuguese regulation, okay, from 2017. And I'm going to show you briefly some results that we have made in some control rooms that we are monitoring, also with indoor air quality equipment. And we see here, pay attention, the colors are different because the recommended illuminance levels are also different depending upon if you have informatics, a computer workstation, for example, or you are in a regular classroom, or if you have differences between black, green, and the white boards in your classroom, okay? So audience, auditorium, conference rooms, like the one that we have here, 500, okay? A normal classroom, more or less 300, okay? So this is a classroom that is closer to us in the O building here. And you see that you have patterns of light within the 300 here, around here, higher and below the standard. But we have a much huger problem above us in room O219, in which the levels of illuminance are not very right. We have light from the ceiling, we have light from the windows, and therefore it is very difficult sometimes for us to project and the students to be able to see this panel, okay? And of course, a little summary, but only a little summary. In fact, we should have in mind that illuminance in every working environment, but in particularly within the studies focus mainly in higher education institutions, we should have this into consideration because it improves your experience in classrooms, impacts learning, sustainability, health, and the general experience, both for teachers and for students. And thank you. I hope you have enjoyed it, our little experiment and demonstration regarding light. Okay, thank you. Sandra.
Oh, sorry, I just have my role as a moderator on the session. Okay. Okay, does anyone else have any question? You were very shy, you didn't want to participate, but there's any question now? You explained everything very well, so they don't have any question.
I'm only going to show you that the levels, this is still working, isn't it? Okay. We measured, let me see if it is possible for us to show. No.
Met in dark mode.
That's focus enough, and here also the same thing. Now the light is fighting with us and does not allow us to show. No. The reflective is different. Without light, maybe. Yes. You can see the changes that were registered during our presentation. Okay. And also now. No, this does not, we cannot show it, no. This is not, no, does not show. But the levels of CO2 rise again above 1,000 parts per million, okay? So, thank you very much. For those who are at home, yes. And now you should go to have a nice lunch and rest a little bit. In P building, you have the map on outside the door. You have the map that leads you to the canteen, to the bar on the second floor. Okay, and then now there must not be any delays during the afternoon. Please, 3 o'clock sharp in the conventry of Christ, okay, to the visit, okay, sharp. No one can get placed there, okay? Okay, so. Okay, so Sandra.
One information, we have spare places in the bus. How many 20 places? More or less 20 places. So if you want, you can take the bus with us at 2:30.
But only registered people. Only registered people, because we have a registration. But for example, researchers can go in the bus with Sandra, okay? Because we must leave this. I must be there at 3 o'clock also, but we must clean a little bit this before going to lunch, okay?
I'll ask you in the entrance of the building, but you are with us, so thank you, okay?
So, everyone at home, thank you for being here. I hope you have enjoyed. I know, I'm not speaking. I think
Agora quer ver se eu conto quando
thank you for being us. I hope you have enjoyed. It's for technical issues, but I should
Vai,